Check, check. Sound good, guys? How's the sound? Got sound good? All right. Good, good, good. Yay. What's happening, everybody? Good. Mike sounds good. That's what I want to hear. Hope everybody's doing fantastic today. So, how about this earthquake in Alaska? How does this happen? At first, a tsunami warning was issued. At first, pretty much expecting a tsunami, um, at least down to the Pacific Northwest of the United States. And considering a buoy jumped 32 feet in 15 seconds, that's astronomical, guys. That's astronomical. Where was the tsunami? Where did it go? Talk about a water anomaly. Oh, wow. Big waves off the coast of Washington on the 18th. Remember the 50 and 60-foot waves off of the coast of Washington back on the 18th? Well, this stuff is kind of starting to, I don't know, make a little sense, I guess. In a random way, it's just taking time. But we look at the global map. Hold on, I'm going to switching here. Here we go. This is a map we've been working on for several days, several weeks actually. Should switch here in a minute. There we go. Basically, all I've done is added the 7.9 preliminary 8.2, but it was downgraded to a 7.9 earthquake up here in Alaska. So 7.6 here. Video output's low for some reason. There we go. Okay, now we're back up. Water anomalies all through here, and this would be considered a water anomaly itself because no tsunami. That's incredible. The news is saying 7.0? Really? This earthquake was the equivalency. I want to show you guys something here real quick. Hang on just a second. Got a lot of links to share with you guys today. Some interesting information that I've ran across. Some of this information is regarding the earthquake. And some other random things that I found that are just interesting. I'm going to share all that stuff with you here in just a moment. But for some reason, our signal is a little choppy today, and it shouldn't be. So bear with me, please. Hang on. Sorry, guys, it's buffering, and it shouldn't. There's no way it should be doing this. What's up, everybody? Here we go. Apologize for the signal. There's no way it should be like that. Just so you know, that's also an anomaly in itself, much like the earthquake. Looking at these numbers bounce up and down, and some sort of static. I don't understand. Some sort of static right now in my signal. It's literally bumping from 206 to almost 4,000. Really strange. A lot of strange energy bouncing around right now. But this earthquake, back to the main talking point. Multiple aftershocks, as you guys are all very well aware of. Look at the depth of these things. 5 miles. Here's an aftershock here that was under 3 miles. Aftershocks, there's actually a deep one. That's over 60 miles deep. So a wide range of depth associated with these things, all from pretty much the same place. Right in here, just offshore of Kodiak, Alaska, which was evacuated last night. Those ominous sirens that nobody wants to hear. They're in a link I will post in the description box. I think it's right here. In fact, I don't know, they're kind of loud. I don't want to blow up your guys' speakers, but there are tsunami sirens right here at this link on this website. If you can see it, I should be able to. There we go. Very delayed today for some reason. The energy is unbelievable. Tsunami sirens here woke people up. They were advised to go to at least 100 feet above sea level. And that's where people were going right here. People were congregating here in Tofino, Canada, fully expecting a tsunami. Basic laws of physics tell us that at these depths, with this type of incredible strength, there should have been a big tsunami. No doubt about it. Don't get me wrong. I'm glad that there wasn't. I don't want to see things like that. But this type of energy, let's just take a look at how strong this earthquake was, just by comparison. Here's the buoy that detected the earthquake just after it happened. This was probably within 1 minute. You see a spike here. Let me see if I can zoom it in a little tighter. Give you guys a little better perspective. I showed it in the video I did, but just in case you didn't see it, here it is right now. I'm going to zoom in tight. Here we go. Okay. What we're looking at is 3725 right on the nose. A 15-second spike, the red line going vertical, represents 15 seconds. Red is 15 seconds. Green is 1 minute. So it went vertically 11 meters in 15 seconds. And you can see on the lower graph, it shows the spike, how it went up 11 meters, which is approximately 32 feet, and back down in less than 15 seconds. That's a tremendous amount of strength. And no tsunami. Seismographs around the world, as you'll see here in 3, 2, 1. Here we go. Seismographs around the planet. Black as coal. Kind of odd there. There's one up in Russia that didn't feel it. That can't be accurate. Let's refresh this page. That is very unusual. How did this seismograph here not feel the quake? And it was also in the northern hemisphere. That can't be right. There's no way that can be right, is it? Let's take a closer look. 1900. Huh. It's showing that it's online, but there is no way that can be accurate. This was picked up very strongly even down in Antarctica. Spain, Ecuador. Here's Antarctica right here. Look, this is Antarctica, thousands of miles away. Jet black. It's a very strong earthquake. South Pacific. Rang like a bell. Look at this. All of them are black. But maybe a couple, and one of those. Look at Arizona. Look at that. Of course, I didn't feel it, but the ground detected the frequency of the primary wave. That's why it's jet black. And it's still vibrating as I do this video. Crazy. I don't know how that's impossible. If that seismograph is not on planet Earth, then wherever Bilibino is, it's not on Earth. No way. That's incorrect, buddy. So anyway, seismographs around the world felt this earthquake, and it probably was felt on other planets. No, I'm just playing. It was not felt on other planets. However, let's look at earthquake measurements. I want to show you guys something that's just, it's mind-boggling to me. There's no way that this much energy and this much water can have this type of a disturbance and not create at least large waves somewhere. Earthquake measurements. The National Institute of Disaster Management. Check this out. This talks about the vibrations produced by earthquakes that are detected and recorded by instruments. Check it out. Look. This is a scientific paper, and they're calling seismographs. Look. The vibrations produced by earthquakes are detected, recorded, and measured by instruments called seismographs, right? We go back to the seismographs. Why are they called seismograms now? See that? Just a side note, that's all. I noticed that change about a year and a half ago. I've been referring to these things for almost 10 years as seismographs. It's a graph. Here's a scientific paper calls them a graph in sentence 2, seismogram in sentence 3. Very weird. But anyway, it gives comparisons to how strong the earthquake is by comparison to, let's say, the intensity of TNT. And I think this is the correct article. Yeah, here we go. Richter scale approximate magnitude over here on the far left. Second column, approximate TNT for seismic energy yield. This is a Joule equivalent, but we'll just stick with the TNT because most everybody's heard of TNT. So here we go. A 1.0 earthquake is equivalent to 392 pounds of TNT. A conventional World War II bomb, that's what a 1.5 earthquake is equivalent to. A 2.0 is the equivalent to, and again, we're referring to TNT as a comparison, that's all. 2.0 is the equivalency of 1 metric ton of TNT. And this would be equivalent to late World War II conventional bombs. Let's jump up to a 4.0. 4.0 earthquake is the equivalency of 1 kiloton of TNT. And this is a 4.0. That is equivalent to a small atomic device. Actually, a small atomic bomb. That's what it says right here. East Asia Summit, Earthquake Risk Reduction Center, New Delhi, the National Institute of Disaster Management. We're just getting some comparisons to try to put these things into a perspective when it comes to strength. We're going to talk about the strength of this earthquake that occurred just a few hours ago in the Bering Sea south of Alaska. Here we go. A 6.0. Let's go back to 5.0. A 5.0 earthquake, that's a moderate earthquake, like middle of the road. The Richter scale, from what I understand, goes up to 10. And 5 would be a moderate earthquake, equivalency to 32 kilotons of TNT. That would equate to the Nagasaki atomic bomb that was used in World War II over Japan. That's a 5.0. Let's go to a 6.0. 1 megaton of TNT. That's the equivalency of a double spring flat earthquake in Nevada of 1994. Let's go to a 7.0. That's 32 megatons of TNT. 7.1, 50 megatons of TNT. The energy released is equivalent to that of a SAR bomb, the largest thermonuclear weapon ever tested. That's a 7.1. A 7.5, 178 megatons of TNT. That's the equivalency of the large earthquakes in Pakistan and Chile, respectively, in 2005 and 2007. Here we go. 7.8 and the 8.0 range. And there is a big difference between 7.8 and 8.0, believe it or not. But 7.9 obviously falls right in the middle of this. But a 7.8 will stay on the conservative side, is the equivalency of 600 megatons of TNT. So if 32 kilotons equals a Nagasaki atomic bomb, that's at a 5.0, 600 megatons would be the equivalency of, actually that's a lot more than a kiloton. That's many thousand Nagasaki bombs. Many thousands. Probably into the millions. So you kind of get an idea of just how strong this earthquake was. And not only strong, but the depth of this thing. Wait for the page to refresh. I'm going back to the earthquake page to show you the depth of this earthquake. Showing a depth of officially 25.0 kilometers. Down here in the lower left. Right down here. 25.0 kilometers. What's that? Approximately 10, 12, 15 miles, somewhere around in there. For a 7.9, that is super shallow. So that strength should have went all through the water, just ripples. It should have produced incredible waves. And to the best of my knowledge, there were none. The buoys are still in event mode. Refreshing the page now. You're going to see buoys in both hemispheres are in event mode. Clear down east of the Philippines, off the coast of the United States and Canada, all across the Aleutian Islands, southern Alaska, obviously, that's where the earthquake began, and that's where the epicenter was at. Clear over to Japan, and clear over to New York, off the coast of New York. Very interesting. Watch. This is where we've been seeing a lot of recent water anomalies in this area here. Okay. Coastal New York. Look at that. Southeast of Fire Island, New York. That's incredible. That's a long ways away. Why it didn't trip these others, I don't know. There's something unique about this buoy that it detected the 7.9 earthquake way up here. in the Gulf of Alaska. And I think this is the buoy right here. Yeah, this is the one that jumped 32 feet. And again, in water column height, that's astronomical. That is huge. Where did the water go? I'm glad that it didn't. Don't get me wrong. But where did it go? Where did the water go? That's a big deal. 32 feet and not even a high tide anywhere. That reminds me of, I'm going to go back here just a minute and show you guys something. Hopefully we'll stay good here. Okay, I'm switching screens here real quick, guys. And I'm going to get a drink of water. Okay, here we go. The 7.6 earthquake, the star icon here that I have next to South Central America, right straight across from Honduras, southeast of Belize. That was a 7.6 earthquake that we saw less than 3 weeks ago. You go up, and it created no tsunami. But we saw water anomalies prior to the earthquake. This large quake up here, we saw coastal high tides, big waves prior to the earthquake on the 19th. Were they related to the earthquake? Probably not. There was a very large storm system that was kind of parked off of the coast of Canada, eastern Canada, British Columbia, in the Pacific Northwest of the United States. In fact, there were 4 that stretched clear across the North Pacific Ocean. And the one was stationary for the better part of 48 hours, producing very large waves into Washington. Some were measured as high as 60 feet. Saw some spectacular videos. So we can't really say for certain that this water anomaly was associated with this earthquake. Chances are it probably wasn't. However, prior to the large earthquake, and I'm going to switch pages again, there was a water anomaly observed in the Kodiak Bay. Let's go back to our links. Here we go. I'm going to switch pages here real quick. And I'm going to go back to, bear with me, I've got a few pages open here. Okay. Okay, they took, the video's no longer on this site, this story here that I used this morning in a video. The video that I wanted to share with you, I don't know, they've reconfigured this story. There was a weatherman from, I want to say the UK, that was talking about this earthquake and the very likely probability that there was going to be a tsunami. He mentioned that Kodiak Bay, the water retreated. The bay went empty prior to the earthquake. That was, in fact, observed. I've been trying to, right in here, the water retreated right in this area. When the page switches, I'll take you guys in nice and tight, okay? Here we go. So I do have one water anomaly that's not associated with the big waves that we saw in Washington the other day, but check this out. I'm going to take you to right here. The earthquake was here. This is where the earthquake was at in the Gulf of Alaska. So, hold up. Where are you going here? Here's Kodiak. All of this water disappeared before the earthquake. It all retreated out. And that's quite normal prior to a tsunami, right? But the water all disappeared. I tried to find it on this particular instrument. I'll take you guys there right now. This is a weather camera. Let's see if I can pull it up here real quick. There we go. Okay, we want to look. Which way do we want to look? We want to look this way, which would be south, southwest. Let's look out into the bay. Here we go. I looked this morning, but the earthquake happened obviously when it was dark, so I couldn't see the bay empty. But this will, that starts right before the earthquake. But you can't see anything on this device, but this is right where the earthquake happened. And then it should take us up to sunrise. The sky should turn blue. And there we go. Okay, let me stop it for just a second. All of this water disappeared during the prior to the earthquake. And it looks like what I'm trying to do is to see if it's still there or if it was absent after the earthquake. This is where the earthquake had the biggest impact. This is Kodiak. You're looking at Kodiak right now. This bay of water disappeared prior to the earthquake from the reports that I got. If any of you were there or know anybody was there that can confirm that, that would be really awesome. This water all disappeared. This is Kodiak Bay. I don't know if it's called Kodiak Bay, but it's the bay that's on the shore of Kodiak, Alaska. We're going to play it through again. Now that's right about the time of the earthquake right there. Looks like a little fog, maybe some low clouds. The water doesn't even look disturbed. Just looks like normal tide. So let's go back. Okay, that one is southwest. Let's look in a different direction. Now let's look to the southeast. Again, this is right near the epicenter of the 7.9 earthquake. And that's right around the time of the earthquake is what you're looking at right about now. Here comes the sun. Let's see if we can. Which direction are we looking again? Southeast? Okay. There you go. See the water? It's undisturbed. Of course, this is hours, probably 4 hours after the earthquake, 4.5, something like that. Maybe 5. But the water is perfectly calm. That is near, or actually not far from, the epicenter of the 7.9 earthquake. This is near Kodiak, Alaska. This is what you're looking at right now. And the reports that I'm getting, this bay was empty prior to the earthquake. And that's consistent with the tsunami. You always hear of that before tsunamis. The water retreats and then it comes back. Well, it retreated and it didn't go anywhere. But that's Kodiak, Alaska. This is near the epicenter of the earthquake. Here's another decent shot of the water that retreated. Looks perfectly normal. Like nothing happened. It's just a reflection. There you go. The road's not even wet. Yeah, this is Kodiak, Alaska, looking to the southeast. That would actually be towards the epicenter of the earthquake. So very interesting to look at the area and put it into perspective. I don't know how that water didn't at least create some extremely high tides, but it didn't. And that was the first time I think I've ever seen an earthquake of that size and strength that had basically no effect on water. And it was very shallow, so the epicenter is out here, and the water was basically undisturbed. And none of these showed any signs of... here's some more water here. This is just a few miles away. This is called Old Harbor, Alaska. And we'll just take a look at it and see. I'm looking to the south. Let's go south. Actually, let's do this one here, east. Let's just take a look and see. I'm just curious as to what this bay looks like, if it shows any signs of anything happening. I haven't looked at this one yet. So this is my maiden voyage here at Old Harbor East. Cycling through right now. Looks beautiful. No problem. Water looks perfectly normal. Some sort of a walkway here. Water looks perfectly fine. Doesn't look like it's been disturbed by anything. No wind, nothing. Looks very, very normal. There's not even any white caps out there. I don't know if that's the camera or if that's supposed to be green like that. It might be the camera. Probably is. Huh. One more look at Old Harbor real quick. I want to look another direction. Sorry, guys. Okay, that was east. Let's look to the southwest real quick. Got a cool video to share with you guys from out here in Greer, Arizona. An interesting observation that was made a couple of days ago, actually right after the big windstorm up in the Pacific Northwest, but there was an interesting video that surfaced from the 19th. I don't know. I'll share it with you here in a minute. Okay, Old Harbor. Again, this is not far from the epicenter of the earthquake. Old Harbor, Alaska. This is a weather cam looking at the harbor, and it's looking to the southwest. Let's go back and do this again. And the water looks like ice. Even though it's not frozen. Now, wait a minute. There's a small little wave there. small wave there. But again, it's very minuscule. Very minuscule for a 7.9 earthquake. So anyway, all of this area here felt the earthquake. People were evacuated on Kodiak Island. They were advised to go up at least 100 feet. And there were no injuries and no damage that I heard of. And that is absolutely awesome. That's great. So we don't like to hear that. And here's the people going to, there was a high school they were advising people to go to that's elevated up 100 feet in the air. But the high school and the high school parking lot, I guess, filled up so quickly that people were trying to find other places to go that they would be safe. But tsunami, moved to higher ground. There's an alert right there. They were just sure that there was going to be a tsunami. Warning, flood wave possible, full evacuation suggested. And that was very justifiable based off of the strength of the earthquake. They were fully expecting it right in here. I don't know, guys. I am mystified by that, as you can tell. I am absolutely mystified by the fact that there was just simply not one. And the initial reports was this thing was an 8.2. Honestly, that is amazing. Pretty incredible. I'm going to show you something else here, incredible here in just a minute. Okay, we did the comparison for earthquake strengths. And in fact, let's touch on this real quick while we're here. I already spoke about how a 7.9 measures up to how much TNT is, like 700 megatons. It's just hard to even fathom. An 8.0, which is one above a 7.9, that's the equivalency of 1 gigaton of TNT. Go back up. 1 gigaton of TNT, which equates to the Toba volcanic eruption that occurred 75,000 years ago. And that's incredible. So a 7.9 is just 1/10 away from an 8.0. And an 8.0 is the equivalency of a very strong volcanic eruption. It's just mind-blowing to me. How that did that is just beyond. And here's another thing that the 7.9 earthquake was compared to as far as strength goes, the 1976 Tangshan earthquake in China. This happened on July 28th of 1976. It was initially, the preliminary reading on this quake was an 8.2. It was also downgraded to a 7.8 or 9, I think it was. Initially an 8.2, downgraded to a 7.8. This one happened on land, or right near a very populated area. Just a bad earthquake. We don't like earthquakes like this. But many people perished. It was one of the worst earthquakes in Chinese history. I want to share something with you of the early warning, about early warning predictions. It involves water. Prior to this large earthquake, and again, this was an 8.2 initially, downgraded to a 7.8. But this is an observation that I'm about to share with you that people saw before this earthquake occurred in 1976. Well water, early warnings and predictions. Well water in a village outside of Tangshan reportedly rose and fell 3 times a day before the Great Earthquake of 1976. Once again, people noticed water anomalies in July of 1976 3 days prior to one of the largest earthquakes in China's history. Well water in a village outside of Tangshan reportedly rose and fell 3 times a day before the earthquake. So a water anomaly was observed by many people in various places in well water. Gas began to spout out of a well in another village. And this was on July 12th. So this would have been 2 weeks ahead of the earthquake. City dwellers. Gas spout out of a well in another village on July 12th and then increased on July 25th and 26th. City dwellers from the downtown area who had fish discovered that the fish were restless, jumping out of the aquarium as if they were wanting to escape. So people in town that had aquariums before the earthquake, fish were trying to jump out of the aquariums. Very strange how these creatures like fish and animals can detect these things, or even before human instrumentation can. Some animals, therefore, may have anticipated the very large earthquake, but that's the first time I've ever heard of fish trying to jump out of an aquarium prior to an earthquake, before it even happened. But the one thing that I could relate to was the water anomaly. People noticed their well water going dry, going up and down vertically 3 days prior to the earthquake. So this one here, it's definitely a mind bender to me. I don't know of any water anomalies prior to this earthquake, other than, at least in the immediate area, other than the Kodiak Bay is what I'm calling this. It went dry. So more than likely, other areas other than just Kodiak Bay, probably all of these areas along here, I would assume. But then again, I would have assumed that there would have been honestly, I thought there was going to be at least a 10-foot tsunami, at least along Canada and parts of the upper Northwest. I really did. And there was nothing. All of this water here, at least it was reported in Kodiak Bay, drained. I don't know how far out it went. All I know is it was observed leaving. So water anomalies do occur during, prior to, and even after earthquakes. It's not uncommon. And all of the water anomalies that we're seeing around, especially North and South America right now, they're trying to tell us something. Like the well water in China 3 days before the very large earthquake. The water was trying to, the water was reacting to energy. And water, for those who were paying attention, knew that something was going on. Much like these creatures here. Let me see if I can find it real quick. Yeah, here we go. This is from Greer, Arizona, what I'm about to show you, which is, just so you know where we're at, right here, not far from the New Mexico border, north and west of Gila National Forest. Again, we're going to Greer, Arizona. You ready? Here we go. This video was taken on the 19th. Watch this. What are they running from? That was filmed on the 19th, right in this area here, Greer, Arizona. I think that those creatures were running to the west, which would be this direction here, I think. It's not uncommon. It happens. But when I see that, it looks like to me something spooked that herd of elk. And they moved. Something prompted them to move and move in a hurry. You know, it wasn't like they were wandering around looking for food. Most of the time, those things, when they behave like that, whether it's something local or they're sensing something much bigger, they're not going to leave a food source and run past potential food. That's what they were doing. They were running past potential places to get food and even water. So when they're moving in a hurry like that, they're either spooked by something that they sense, because let's face it, animals are very sensitive to natural disasters. It's a known fact. It's science. They've proven it. So this again, these elk were spotted running in a pack and in a big hurry in Greer, Arizona, right in this area here on the 19th. And I don't know why. Maybe they felt this big earthquake that was coming that we just felt last night. I don't know. But the animals of Earth, birds. There was a big event down in Texas not too long ago, a couple of years. Birds were behaving very strangely, and I think it was prior to a large hurricane. Birds were actually landing on the highway. Do you guys remember that? It was in the Houston, Texas area. It was during rush hour traffic. Birds were landing along the freeway. They were less afraid of 4,000-pound cars than they were whatever they were sensing in the sky. They landed right along the freeway. This was in Houston, Texas. I want to say, you know what? It may have been 2018. I'm sorry, 2017. At the latest, 2016, but possibly 2017. The birds were so scared of something had them spooked in the sky, because normally they would have been flying over the cars and the city unless they were looking for a building. These birds landed along the side of the road. Cars were driving by these birds and they were not moving. And there were hundreds, probably thousands, I don't know. But it was in the Houston, Texas area. Prior to, Hurricane Harvey was several weeks down the road, so maybe it was 2017. But it's very interesting how animals are super sensitive to planet Earth. Here's some deer. Now, that's an old video. I think that one's out of Japan. Those deer were right in town, setting along a busy street. You know, they were less afraid of humans and cars than they were of something else. But anyway, guys, I'm still mystified at this very large earthquake. You guys got any ideas? Where did all that energy go? That's unbelievable. That is unbelievable. It's like there's something divine is watching over this planet. Let's put it that way. And that's good. That's good. Because mathematically, there should have been a tsunami with that earthquake. You guys know that, right? There should have been. That was way too shallow and way too strong. So, okay, Greer. There's the buoy again. Yeah, here's the buoy again near Kodiak. 32-foot swing in less than 15 seconds. We're right at it. Probably less. That's a really, really big deal. So I'm very glad that it did not happen, but the fact remains that it didn't. How? It's incredible. Took my son to school this morning on a different note. It was 34 degrees out here in Arizona, which, isn't uncommon, but it wasn't forecasted earlier in the week or over the weekend. We were supposed to have a couple of cool days and then warm back up, which it is going to warm back up today, but the temperature is going to double today. The temperature was 34. It's actually going to more than double. The temperature was 34 degrees when I took my son to school, and this afternoon it's supposed to be above 70. It was warmer in New Jersey this morning. At the same time, at like around 7:15, it was warmer in New Jersey than it was in South Phoenix, Arizona. And this weather does not know what it wants to do. But again, multiple aftershocks, back to the earthquake, multiple aftershocks of varying depths. Here's one here that's less than a half a mile. So that's not uncommon. These aftershocks could continue for better part of a week into 2 weeks. Who knows? There could be another, like the large earthquake, and I've seen this happen many times, but this earthquake here that I spoke of, the 1976 earthquake, it started out as a prelim 8.2, downgraded to a 7.8. There was another 7.1 aftershock that came 16 hours later. So that's just something to consider. There's always the chance of larger aftershocks. So this may not be completely finished. I mean, there's smaller aftershocks going, which is very, very normal. But don't be surprised. Don't be surprised at all if you see another 7-pointer. It would not surprise me at all. It happens. It happens. And you know what? I can't. Here's the thing, guys. I'm a numbers guy. I don't know if I've ever shared that with you guys, but I am a numbers guy, plain and simple. I'm not going to really go into it in any great depth because there's a lot of people that are numbers people. I'm just one of those people. Not unique. I'm just a numbers guy. Numerically, this doesn't make sense. I think that's why I'm sitting here rambling about it. Because numerically, it defies the laws of motion, the basic laws of physics. Doesn't make sense, guys. But in a good way. Like the 7.6 that was in the Caribbean Sea. What was that? 2 weeks ago? No tsunami and no damage. Great. We love no damage. I don't want an earthquake to ever damage anything. But it's just how Earth is. It's always been like that. That's the planet that we live on. But numerically, this one here, I can't do the math. It's like numbers have changed. It just numerically does not make sense. In a good way. So I'm not complaining. I'm just saying it just does not make mathematical sense. Nope. 2 + 2 = 5 here. But don't be surprised. I'm looking right now. Aftershocks are approximately 10 to 15 minutes apart. They vary, fluctuating. 1801, 1826, 1911, 1926. 15, 20 minutes apart. Maybe sooner. It just depends. Ranging anywhere from 3.3, 4.3, 4.5, 5.0, 4.9. Boy, there's a bunch. 4.6, 4.8, 4.7, 4.9. Just about got every number covered in the fours. And then now it's been upgraded. Nope, the same. 7.9 at 25 miles deep. I thought it changed once again. But nope, still a 7.9. At 12 miles deep. Wow. So don't be surprised if there's more aftershocks which there's going to be more aftershocks, absolutely. I would say they'll probably, based off of that signature, a 7.9, you'll probably, more than likely, we'll see an aftershock of 6.2, somewhere around in there. But again, this one is defying mathematics, so we may not see any more. It wouldn't. That would probably make more sense. But seismographs, as we saw in our scientific paper, are still jet black and probably will be for the next 24 hours. That was a very strong primary wave and a secondary wave that went through the entire planet except Bilibino. Detected nothing. So there's a steady frequency of some sort here that resonates hour after hour after hour after hour. So I don't know if this is defective and it's just simply not working properly, or if it seriously is the only seismograph on planet Earth that did not feel the 7.9 earthquake. It's probably a malfunction, but the rest of them did. This one here felt it, but it's not jet black like the rest of them. Every other one, with the exception of some of, like this one here in the Deep South Pacific, obviously a strong signature, but it was felt very strongly in Antarctica, New Zealand, Pennsylvania. Now here's another one. This is Tixi. So Tixi should have felt it. Tixi, for those of you that don't remember, Tixi was showing us something last year. This is a seismograph that sits up near the Arctic Circle, and it's just inside the Arctic Circle. Last year, for the period, I don't remember the exact dates, I'd have to look, but I do have it archived, I do have it saved. For about a month, this seismograph right here showed us something out of this world. I don't know what it was. There was actually somebody that went and checked the machine physically to make sure it wasn't malfunctioning, and it wasn't. But it was showing us some exotic signatures, like it was picking up a really unique frequency of some sort, and it was being translated onto these graphs as almost like a type of sacred geometry. If you've ever seen sacred geometry, that's what it was kind of looking like. It was being translated onto the graph as like a form of sacred geometry. And this went on for the better part of a month. And then it slowly went off of the chart and went back to normal. And you can see here it detected the earthquake just like every other seismograph did. And it's working perfect. So we'll see again this year. I think it was in February or March of last year that this started to show us these really unique signatures. So we watch Tixi every day, and we'll be watching again this year, looking for that frequency. And you know what? It could be telling us that it's detecting, a frequency from space or something like that. I have no idea. I've never seen anything like that before. But I do watch these seismographs very closely, track energy. Can't now because they're jet black, but when they look kind of boring and there's nothing on there to see because there's no earthquakes, that's when you find energy moving around your planet. And we've tracked energy moving across the United States from East Coast to West Coast and vice versa. You can see these signatures pop up on here just a few minutes apart from each other. And that minute or two, depending on which direction it's moving, tells you which direction the energy is moving. So it's kind of interesting, and it makes you think, what's causing the energy? There were no earthquakes. What was that? So it kind of sheds some light on your Earth, what's going on in the crust of Earth. These things are very sensitive instruments. They can detect lightning. They can detect, depending on if they're close to roads. Typically, they're not set up shop, so to speak, near a road, because heavy trucks and stuff like that, they can detect those also. They can detect aerial ordnance, and of course earthquakes. But this is the buoy right here in the Bering Sea and the Gulf of Alaska, and you can see this one here. That, guys, that's absolutely astronomical. Usually a tsunami signature is just about in here. For a significant quake, I'm talking 7, 7.2, 6.9, even a 7.4. The tsunami signature on the buoy, and it may ring across several buoys. Won't be very high at all. This is astronomical. It really is. I'm just being 100% honest with you. That is astronomical. Wow. There should have been a tsunami all through here based off of that amount of energy. Absolutely. I'm glad there wasn't. But as you can see, the buoys are still in event mode. They will be for several hours, clear up until tomorrow. Some may resonate longer than that, but typically not. Once they go into event mode, they stay that way for a period of 24 hours, even though a potential event is long gone. They will reboot in 24 hours. So late, actually tonight, while we're in bed, they'll reboot, and tomorrow they should not be in event mode. But you can see clear down into Northern California, event mode. Oregon, event mode. Off of British Columbia, Northern Washington, event mode. Obviously off the coast of Alaska, all along the Aleutians, every single one with the exception of a couple, event mode. All the way back down towards northern Japan, event mode. Let's just take a look at that one. I haven't looked at this one yet. Let's look and see. The Northwest Pacific Basin. This is over by Japan. Okay, that right there looks like a lot, but it's actually not. If you look at it very closely, it's just a few millimeters. It's not that much. That just tells you how sensitive these things are, right? Here's a very good example. This is a buoy that was probably, 1,000 miles away, maybe further. It detected the earthquake. And you guys know how buoys are configured. They're like a three-part configuration. There's a wireless, actually it's wired, everything's wired, but it transfers a signal from the sea floor up to the surface of the water, and there's an instrument that's attached to the sea floor, and then they communicate, and that's how it determines the water column height based off of its position on the sea floor. It doesn't just magically measure the depth of the ocean. But you can see that this is way over by Japan, and it detected some very strong signatures, and even though it's not great movement, it still detected it. You're talking less than an inch. That's how sensitive these things are. And then it kind of got a little unusual right there, but drop off there, which that's very normal. Yeah, that's very normal. Wow. That's way over here. Let's look at the one down by the Philippines real quick. See the entire ring of fire. Let's look at this one. That's interesting. 7.2. Not too much going on here. I mean, it looks like a lot, especially the red, but it's not that much movement. But you're talking a few thousand miles away, and it's still detected the energy. So, but again, it's not that much. You're talking maybe a couple of centimeters. But these things are very sensitive, and they can detect the energy thousands of miles away. That's how they're designed. But that's not as much as it looks like. But still, it detected it way out here. And if I'm not mistaken, there was a small earthquake in Hawaii not too far after the 7.9 earthquake. And there's actually one buoy in event mode off the southwest coast of Hawaii. Let's look at it. This is the first time I knew it was in event mode, but once I knew that there was no tsunami, especially in this position here, I knew that they were okay. There were not going to be any tsunamis. But you can see a little bit of movement. Not that's about normal. What you see with any large earthquake. Maybe 4 inches or something like that, which is still, it's a pretty big deal for as far away as it is. That's, 3 or 4 inches. That's down in southern or southwestern Hawaii. 3635, 3645. So, yeah, pretty impressive for as far away as it is. But no water problems. No water problems at all. So that's good. That's a good thing. And then I want to look at the one in New York real quick. And how are we looking in Ecuador? Looking good. Let's see if it registered anything. Ecuador has been a very busy place the month of January of 2018. Showing some breaches. That's what I call those things. Those are data gaps. I see those from time to time, and honestly, I don't know what they are because they're so inconsistent. You never know when they're going to happen or what they mean. I don't think they were associated with any type of earthquake, but don't know. But as far as I know, everything in Ecuador right now is looking pretty good. I want to look at this one in New York real quick. And it's interesting how this one can detect and be put in event mode by an earthquake that's even farther away than any of these. But it happens all the time with large quakes. It's not uncommon. It is kind of uncommon, however, to have an earthquake in the Pacific trigger especially the North Pacific, trigger a buoy over in the Atlantic, especially off the coast of New York. It doesn't happen that often, so that what you're looking at is super rare. So over here, you can see the water column went up, opposed to down in the Philippines. See there? This went up. In the Philippines, it went down. That was over 2 feet. Wow, that is very interesting. So that was a significant change in less than a minute off the coast of New York. All right. So 5.36, I'm just talking out loud, 3. That's interesting. I don't know, guys. Very interesting times we're living in right now. Very, very interesting. 2018 picked up right where 2017 left off. And we're just getting started, my friends. Literally just getting started. So, be prepared, be safe, be wise, be brave. Got to be all of those things. All of those things and more. We live in very interesting times. I've noticed a lot of other things that I haven't even shared yet. Don't know how to share it. but I will eventually. And again, it's nothing bad. It's just the uniqueness of the times that we're living in. It is just so incredibly unique. So, I will. I've observed some things in the past that, quite honestly, I don't know how to present to you guys, but I will. Back to the herd again. Something spooked a herd of probably 100 elk in Greer, Arizona. I don't know if they felt an earthquake, if they felt an earthquake coming. Certainly wasn't a storm or a tornado or anything like that. We don't see those very often out here. In fact, we have not had any storms in Arizona for quite a while. They had a snowstorm. What's up, Randy? We had a snowstorm up in Flagstaff in the northern part of Arizona a few days ago that dropped several inches of snow in the Flagstaff area, but not uncommon. But as far as these guys here running from any type of a storm, it's very doubtful. Was it an earthquake? Were they just relocating because of a local anomaly? I don't know. And again, it's not uncommon. It's just kind of interesting considering all things considered that's happened in the last couple of weeks with the earthquakes, with the water anomalies, water retreating, many tsunamis in South Africa, South America, water disappearing in North America, the huge waves, the large quakes. We had a wave in Mexico here, less than a week ago? Today's the 24th, right? No, today's Tuesday, the 23rd. Okay, the 19th, I think it was. Less than 5 days ago, a woman was pulled out to sea over a half a mile by a rogue wave. She was just walking along the shoreline. And the next thing she knew, she was half a mile out into the ocean and could not feel the ground. She stayed out there and swam for, she said, nearly 60 minutes before she was able to get back to a depth to where she could walk back to where she originally started, which was also a half a mile away. So that was incredible. And that was down off of the coast of Mexico. And that was in the past week. So a big rogue wave. And again, we're talking about the same area that we're seeing these water anomalies. Right in here. Water anomaly here. Water anomalies here. We want to keep something in mind. I want to just, so we can keep things in perspective. We have a man directly parallel from where this earthquake is. And I'm going to finish on this because this is kind of important, okay? Here we go. Take notes for whatever this means, because I think this puzzle may be starting to reveal some important pieces. 7.9 earthquake here. 7.6 earthquake here. Water anomalies all over the place. And we're going to start putting these on a map. I'm going to update the map and try to make sense of all this. But I want you to come straight across on your latitude right into this area here. I've shared with you pictures. A gentleman by the name of Philip from Newfoundland has been sharing with us for the last couple of weeks. He's noticed a new normal in the high tide in Newfoundland, right in here. And that is directly parallel with your 7.9 earthquake that happened today with no tsunami. But over here, there's a new high tide, and it's permanent, of 4 feet, maybe more. He's noticed this since October of 2017. I'll share the pictures in a video in the next day or two. But this area here has a new high tide. He says it will not go away. It hasn't gone away in over 3 months. The boat dock that he drives past every day is nearly underwater. And it was a boat dock. You tied boats off to it. Now you can't safely tie boats to it because it'll damage the boats because the water is so high. So you got another water anomaly up here that we have to keep into consideration, and it's directly parallel with the 7.9 earthquake of today. Are they related? Have no idea as of this moment, but there is a water anomaly straight across here, down into here, down into here, 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 over here, down in Uruguay, and more than likely in many other places as well. We're just unaware of it. That's all. But look for more aftershocks in the Gulf of Alaska near Kodiak. Don't be surprised if you see yet another large earthquake, a significant quake over 6. It's very possible when large events like this happen. There usually are, not always, but usually, and can be a large aftershock afterwards. But it's no guarantee, just like with the tsunami with this case. There was no tsunami, so nothing would surprise me with respect to this event. But you can count on definitely more aftershocks. Don't be surprised if there are much bigger aftershocks than a 6, maybe a 6.2, 6.3 wouldn't surprise me at all. But they had the travel times and everything all marked out. As you'll see here on this map right here, the travel times on average for tsunamis, and tsunamis, guys, can travel up to 500 miles per hour. So again, they did mathematics to make this map, and based off of, and it's not complicated, strength of the epicenter, how far out it should mathematically expand based off of the depth of the water and the depth of the epicenter. This is what they were fully anticipating, and it didn't even come close to that. So it did not even come close to that. So if you guys want, I'll stay on a little longer. If some of you are just getting home at the end of the day, if you want me to stay on longer, I will. Let me know. We're just basically recapping the event from overnight last night, and how there was essentially no tsunami after such a strong earthquake. It just doesn't make mathematical sense, to be honest with you. There's an aftershock there of 4.1, a mile and a half deep. There was just another aftershock. But back to the tsunami, they had the travel times all mapped out for us. Like I said earlier, tsunamis can travel up to 500 miles per hour. There's a few variables involved, not that many though. You can calculate tsunamis like you can CMEs and their impact with Earth. And over the years, I've learned how to do it. It's not that hard. If you really want to learn something, you can do it. It just takes perseverance, and it takes you have to want to learn it. And I learned how to track and calculate the speed of coronal mass ejections off of the surface of the sun. It's a little tricky when it comes to the exact time they're going to impact planet Earth, but you can do it if you really want to, because the thing of it is, it becomes complicated because of the distance between the Earth and the sun and what it can do in its travel time. Density, you have to kind of approximate. I'm talking about CMEs. And I've tracked CMEs to Earth. Well, basically, I've tracked speed. I remember the first time I calculated the speed of a CME, and I got attacked. I got attacked because the person could not convert kilometers per second to miles per hour. So because they didn't understand the math, they attacked me. but they were leaving out a very important part of the equation. Just like when you're calculating a tsunami, you have to calculate a few variables, and you should get, a plus b equals c, or x times y equals z. You should get that. That's what should appear. Just like with a CME, I would calculate the speed of a CME, and if it stayed on its direct course, I could tell you when it was going to arrive at Earth. It wasn't that hard. Got a little tricky because of its travel time, and then they could thin out by the time they got here, and that's when I learned how unique Earth was with respect to battling big stars, is the fact that Earth is so small. Earth is hard to hit. I don't care how big that CME is. Earth is very small. So that CME could be as big as the entire universe. And it's only going to do so much damage to Earth because Earth is small. But I detected used to calculate the speed. I don't do it anymore. In fact, there haven't even been any solar flares or CMEs to even calculate. But Earth-directed CMEs and solar flares, they go up to many millions of miles per hour. And like with respect to, and that's based off of, their density and its size. There's not that many variables involved, but a few. In fact, there's more variables involved in tracking and predicting a tsunami. And I think that's why that, it was miscalculated today. I'm still shaking my head. I can't. 7.9, that's almost an 8.0 on the Richter scale. That was less than 20 miles deep. That's nuts. That's absolutely nuts. Water should be sloshing around in the Pacific Ocean right now as I do this video. It's like nothing ever happened. It's like the hand of Almighty God reached down there and absorbed the vibration of that earthquake, and it never went through one water molecule. It's gone. And that's a good thing. We like that. But that's very interesting, guys. That is very, very interesting. Yeah. They, and even myself, and I'm not an expert. I'm a very seasoned observer, absolutely, but I'm certainly not an expert. But I just knew, based off of some very quick math, that there was going to be a tsunami. Absolutely. At least in the Alaska, Canada area, and possibly parts of the northern Pacific Northwest of the United States. I just knew there was. Now, how big? I wasn't really sure on that. I knew it would be maybe an hour or two away, so I knew there was some time. That's one good thing about tsunamis and even CMEs. If, let's say, there was a really powerful, that's honestly why I taught myself how to calculate by using the SOHO spacecraft. When I see a CME or the SDO instruments, if they're Earth-directed, I would calculate the speed. Once I knew the speed, I could guesstimate within a couple of hours, because a lot can change between the time it leaves the surface of the sun and the time it starts interacting with Earth's magnetic shields. But you could determine millions of miles per hour. And I had people arguing with me back in 2011, 2012, saying, there's no way, that your math is right. And then it was right. It was right, of course. It can go 1 million, 2 million miles an hour. Absolutely. So what happened here with this? Don't know, guys. Tsunami waves, you can see right here, according to this map, were predicted well past Hawaii into Southern California. Didn't happen. And we'll take it. We'll take it. So if some of you guys are just joining in, I'm just rambling on about the lack of water movement during this very strong earthquake. That was almost the equivalency of a volcanic eruption. It was that strong, and we can discuss that again. But I marked it on this map that we've been following water anomalies. I can actually add many more buoys on this. There'll be so many that they won't even show up on our globe. But this here was related to the 7.6 earthquake that struck in the Caribbean Sea a little over 10 days ago, and the water anomalies in the hexagons that I marked that were prior to the 7.6 earthquake. What we need to try to find out now is if there were water anomalies, which we know of one in the Kodiak Bay off of the, actually right on the shoreline of Kodiak, Alaska. I was told and heard that the bay drained. It went completely dry of water, like we're seeing in Navarre, Florida, like we're seeing in Tampa Bay, like we're seeing in Ecuador. We're seeing water disappear, but no immediate earthquakes or tsunamis like we saw today. So we're just trying to piece the puzzle all together. And then right over here in Newfoundland, we can add to the map what looks like a permanent water anomaly, a new high tide that appears to be permanent. The observer has been watching this since October of 2017, and his normally dry boat dock is now almost permanently underwater by a depth of 4 feet. That's a lot of weight. That's a lot of water, and we've got pictures of it. He just updated him the other day, a couple days ago. His name is Philip from Newfoundland. And it's directly in line with our friends in Ecuador. So we've got water anomalies all through here, guys. All through here. Water's trying to tell us something. Just like the earthquake back in what was it? We talked about it earlier, back in 1976. The earthquake in China. I was comparing this earthquake to the strength of different things, and that was one of the things that came up. An earthquake back in 1976 in China that was one of the strongest that they had ever recorded, and it was just an incredible earthquake. That's the strength of this one here. 7.9 today. This one was a 7.9 back in 1976. Did a tremendous amount of damage in Japan. But the thing of it is, prior to the earthquake, there were early warnings and predictions, or not, well, there was predictions, I think, but there were observations that people noticed, and one of them was water anomalies. Well water in a village outside of Tangshan, where this earthquake occurred, right over here in northeastern China. Well water in a village outside of the town reportedly rose and fell 3 times a day before the great earthquake. And it was a 7.9. Initially, it was an 8.2, exactly like today. But I think it was downgraded to a 7.8. But initially, it was an 8.2, downgraded to a 7.8. But there were water anomalies prior to the earthquake. And there was also something else that was very unusual. Gas. Doesn't say what kind of gas, but it says gas began to spout out of a well in another village. People in the city who owned aquariums noticed that their fish were trying to jump out of the aquarium. That's nuts. I've never heard of that, but this goes back to 1976. And these are observations that people made prior to a very large, powerful earthquake that was equivalent to the one that we saw today. 7.9. This one was in 1976. We were just making comparisons to how strong this one was today with lack of a tsunami. And this quake today, a 7.9, falls in between a 7.8 and 8.0, but we'll take the conservative side of 7.8. That's the equivalency of 600 megatons of TNT. And that did not have enough horsepower to move any any water in the Gulf of Alaska, luckily. But mathematically, it should have. Absolutely. That's astronomical. That's 32 feet water column height change in less than 15 seconds. That is incredible, guys. For real. So, pretty big deal. Very big earthquake. Very interesting times we're living in. There's some weather cameras here at the Kodiak Island place, just miles from the epicenter. In fact, we can look at a couple of other ones if you want. We can look to, let's see here. Can we see the bay? No, we can't. Can we hear? Yes. No. Yes, we can. Let's look at this one. I think we may have already looked. This one might be a different one. Let's look and see. Okay, this is right about the time of the earthquake. And then we'll see the sun begin to rise right around in here. It's probably updated a little bit since we began doing it. Yeah, it has. It looks fine. There's nothing going on here. Nothing to see. And this bay is the bay that reportedly was empty, or the water at least retreated a long way prior to the earthquake. And that's what kind of gave people a heads up in the local area here at Kodiak, Alaska. Like when you see Tampa Bay drain, you're kind of like, okay, something's about to occur. A natural disaster of some sort, whether it's a tsunami induced by an earthquake. When you see water just disappear like that, it's a sign of something. Well, the water disappeared, and sure enough, there was a very large earthquake. But the thing of it is, there was no tsunami. So it's kind of interesting in that regard. Very interesting. But nevertheless, the water is looking great. In fact, here's another look at. Let's take a look at this one. Which one are we looking at here? You can see water sitting here just as peaceful as it can be. And that's good. Okay, we're looking to the northeast. Let's go up to here. And I checked out all of these instruments, and I didn't see any type of sky anomalies prior to the earthquake. Nothing unusual at all. You can see the water here looks pretty much looks normal, looks undisturbed. Might be a little shallow. Let's look again. Let's watch it all the way through. No. Undisturbed. And this is just right around the corner from Kodiak. Just a few miles to the north of Kodiak. But the water is just as peaceful as it could be. I mean, it's a normal day. That one that's Kodiak. Let's go to Port Lions. This one is to the north and to the east. Let's see if we can see anything here. We'll look to, let's check this one out. Actually I haven't looked at this one yet, guys. This one is southwest. It's called Port Lions. Let's play it. And then we'll wrap it up with the elk running across the road in Greer, Arizona. Okay, this is just... Oh, wait a minute. No, that was snow. I thought that was water for a second. So this would have been after the earthquake. No sign of anything at all. Some people there. What were they? Probably waiting on the tsunami. There's a truck there. 2 more vehicles there. I don't know. They may have came down to watch the water because, again, this is just not far at all from the epicenter of the earthquake. And nothing happened, which is good. It's just hard to mathematically digest, I'm just saying. So anyway, I'll post the link if you guys have not used these cameras. They're very interesting. You can go anywhere most of these work. I will say it's a good site as far as reliability. A lot of the sites anymore, especially with regard to fire in the sky, I used to be able to go to cameras, and they were all very reliable. If there was a meteor event, like say for instance, the big meteor that came in the atmosphere over Michigan, here just within the last, week or two, I could go at a couple of different meteor all-sky camera sites, and you could usually find a camera within range that you could catch a glimpse of it. And now you basically have no chance. I don't care. Even that one there over Michigan, cameras are not going to pick it up. And 3 years ago, any type of a fireball event, with the exception of the upper, like up in the Montana and the Dakota area, there's not a whole lot of cameras, at least with the networks that I use up in that area. But anywhere else, California is loaded with them. But they are incredibly consistent with regard to being offline when there's an event. Just like there was a big event here in Central California about 3 or 4 days ago. Large fireball traveling north through right in the center of California, from Los Angeles to San Francisco. And again, there's a huge network of cameras that observe the sky in California. And they're open to the public, you know. Come join the hunt, chase these meteors, right? Well, when you hear of an event and see an event being reported, and you go to the cameras to retrieve the event, good luck. Can't do it anymore. Nope. You may find one out of 50. And prior to, say, 2015, you had about a 75% chance, 7 out of 10 you could find, no matter where they were at. Alabama, Texas, New Mexico, Wisconsin, New York, California had a lot of cameras that were very, very good. Not anymore. If there's an event, those cameras are off 9 out of 10 times. And it's just the way it is. So that's why I don't do fire in the sky news anymore like I used to. There's exactly why. Because I cannot find anything to present to you guys. So that's why I don't do it. The cameras are off. Oh, they're on, but they're looking at dark skies. But that's fine. We just move on to other things. Back to the buoys again. I'm just making another quick pass and see if I missed any. Maybe we got some over by India or Indonesia. This buoy right here, historically, I forget if it was this one on the east or the one on the west. It was not uncommon back in 2012, 2013. I think it was this one right here, to see this buoy make an adjustment of over 800 feet. I'd seen it before years ago and never could decipher whether it was an anomaly or not. I'm assuming that it probably was, but it sure didn't look like it on the data. I know it sounds crazy, but saw it multiple times in this area right in here for actually multiple months, and it would do it randomly without an earthquake. And you got to keep in mind, this area here saw one of the biggest earthquakes ever recorded on Earth and the largest tsunami, one of the largest ever recorded, that went over into Indonesia. That was back, I think it was 2004. So we always pay attention to the buoys. The buoys are typically a very good source of information, much like the sky cameras used to be, and they are just not anymore. In fact, you know what, guys? Those sky cameras used to be one of my daily stops. I would go there every single day. I quit going. I don't even go to the sky cameras anymore. Nope. There's nothing to see. Nothing to see. You won't find anything either, but yeah, if you do, you're incredibly lucky. But listen, guys, it's been my pleasure. I won't take up any more of your time. Just to kind of recap, the main focal point of this live stream was I still cannot, I don't know, mathematically understand what happened to the energy from this earthquake. Don't get me wrong, I am thrilled that it didn't follow suit like many of the other 7.9 earthquakes that we've seen on Earth, and understandably so, because it was offshore. We get that. That's good. Like the one in the Caribbean Sea, it was offshore, away from people. If they could stay away from people and God's creatures all the time, that's wonderful. But that's not always the case. But for this to not produce a tsunami of some sorts is just mind-boggling to anybody that it's just mind-boggling. Look at that. That's a 32-foot jump. I don't know. A buoy washed to shore today in Oregon. So it must have broke loose during the big waves the other day. You know what? I believe that. That can happen. It does happen. It has happened. Buoys are connected together physically. They don't just sit out there and float randomly. Shoreline buoys, typically they're in networks. Depending on how big the network of buoys is, they're connected together by cables that lay on the seafloor. So more than likely, I just saw a comment from Carpenter about a buoy that washed ashore in Oregon. More than likely, the waves, the rough seas prior to this big earthquake. In fact, there were rougher seas by a low pressure system than there were by a 7.9 earthquake. But the low pressure system broke a buoy, and I probably was looking at the buoy the other day. It was, I don't remember now, there was a coastal buoy off of Oregon, not a real close to the coast, but off of the coast, that was in event mode on the 18th, the 18th. Oregon, I think it was this one right here, the Newport, west of Coos Bay. I think that was the one that was in event mode. But apparently it or one of these has washed to shore. You know what? That is an option, Vince. Maybe it was deeper. That's the only thing that makes sense. If the earthquake was, if they didn't get the depth right, I don't know. It just doesn't mathematically make sense. An earthquake that's 12 miles below the surface at a 7.9 and no tsunami. That's just, I'm still shaking my head at that. And maybe it was much, much deeper. Maybe it was 112 miles deep. I don't know. It almost have to be. So anybody else? What's happening? Do I think it was a... You know what? I never looked at it from that angle, but Lee DeMio, was it a fake report? No, I don't think so. I think there were too many people in Kodiak that probably felt it. I don't know. It's just not a typical earthquake, guys. I am going to look into that and just see how many people felt this thing. Is there anybody on here that felt this earthquake? You're welcome, Cynthia. Is there anybody on here that felt this earthquake? You did feel it, Cryptic? All right. Cryptic felt the earthquake. So it wasn't a fake event. Something did happen. More than likely, it was a big earthquake. I understand that there's earthquakes. We just saw a 7.6 earthquake that didn't generate a tsunami off the coast of Honduras the other day out in the Caribbean Sea. And if I'm not mistaken, that earthquake was slightly deeper than this earthquake was. And what was unique about that earthquake, if we go back to the buoys, let me show you something. And again, you guys, it goes back to being a numbers person. I'm a numbers guy. And 2 plus 2 is equaling 5. Okay. 7.6 earthquake right here. This instrument was unfazed. This instrument, unfazed, felt nothing. 1,000 miles away, off of the coast, not right next to, but off of the coast of Ecuador. This device and this device were both in event mode right after the earthquake. 1,100 miles and 1,600 miles away, respectively. The buoys closest to the earthquake were not registered in event mode. However, this device right here in the central location of the Gulf of Mexico went into event mode. It felt the 7.6 earthquake. So I don't know if that's got something to do with the composition of the plate where the earthquake occurred, and that's just how the energy traveled. It bypassed these buoys that were within 200 miles of the epicenter. The water or the buoys did not feel anything, but yet a buoy 1,600 miles away did. You know, again, you're like, how did that happen? I don't know, guys. Again, it's just super interesting times that we're living in, and we just got to keep our eye on the ball. It's as simple as that. A lot of unique things going on, and there will be more to come, I'm sure, as we move forward into 2018. The weather has certainly not changed since 2017. It's probably equally as intense. And I want to thank you guys for confirming that you did feel the earthquake. I believe you. A 7.9 earthquake, I have no doubt that type of strength, it probably did whatever it wanted to do, with the land around it. I was just talking to a guy less than a week ago. He used to live in upstate Washington in the Pacific Northwest, and he was telling me about an experience that he had with an earthquake back in the, I want to say 1980s, when he lived up there many years ago. The earthquake started. He felt it like many of you did that felt the earthquake today. He ran outside to get out of the interior, of his home. He just kind of panicked, ran outside, which probably wasn't a bad idea because he was away from any falling objects inside of his house. And he stayed in a clearing in his yard, and he said as he looked down the street, the streets, the yard, the entire land that he was looking at had waves going through it. He said he felt like he was in a dream. He couldn't believe what he was looking at. But there were ripples going through the ground, like there was water underneath the surface. He couldn't believe what he was seeing. And then, of course, things began to fall, and power poles and power lines, things like that, and trees were swaying back and forth, some breaking, but the ground just rippled with waves. And it wasn't even a 7.9 earthquake. I think it was just over 6. So a quake of this strength, the seafloor was probably doing cartwheels. And the water just simply didn't respond. Ah. Holy cow. But listen, guys, I really appreciate you hanging out with me today. I hope we've learned something. Thank you for sharing your experience with the earthquake today. You know, I've been in hurricanes and tornadoes. I've never been in an earthquake. The closest I was to an earthquake was a 7.2 near the Baja California. Actually, it was the Gulf of California. Back in 2010, the lights, or a couple of lights in the house, began to sway back and forth. The vertical blinds in the house began to sway back and forth. In fact, they were kind of vibrating, and I was 270 miles away from the epicenter, 275. And the house felt the earthquake. We could barely feel it, but the house was feeling every vibration. And we were 275 miles away from the epicenter. And that was a 7.2 in the Gulf of California in 2010. I want to say it was on April, don't quote me, but you can check it out, probably April 5th, April 4th of 2010, a 7.2 in the Gulf of California. I felt that one just barely. The house, like I said, the vertical blinds were swaying and vibrating, lights swaying back and forth, probably 5 to 6 inches either way. Nothing like what was experienced today, I'm sure. Nothing even close. But again, they're very, very strong. So it's just interesting. But guys, I will leave you with the herd of elk. This is in Greer, Arizona, over by the New Mexico border, east of here. Looks like something may have spooked these creatures, and they were relocating in a hurry. Probably a couple of hundred elk. And that was over in Greer, Arizona, the 19th. That was recorded about 4 days ago. So animals are very sensitive to the earth and impending natural disasters. In fact, we were just talking about a large earthquake in China where fish were trying to jump out of an aquarium the day of a very large earthquake. It was an 8.2 preliminary, just like today, and was downgraded to a 7.8. That was back in 1976. But watch for more aftershocks. There will be plenty up here. They will probably continue for several days. Don't be surprised if you see an aftershock of greater than 6. Wouldn't surprise me at all. I want to thank you guys for hanging out. It's been my pleasure. I don't know. I just wanted to talk about why there was no tsunami. I'm glad, but mathematically, it wasn't deep enough. Going based off of the numbers that we have, 12 and a half miles deep, there should have been a significant tsunami. But there wasn't. That's good. We're not complaining. We're just puzzled. I'm puzzled. So thanks for joining, guys. John, Mercury Messenger, Steve, Cryptic Patriot. You felt the earthquake, Cryptic Patriot. Peggy Harlan, Truth Templar. It's been my pleasure. Thanks for joining. As always, thanks for sharing your most valuable commodity today with me, and that is your time. Time is our most precious commodity. Thanks for sharing your time with me, and as always, be safe out there. And I'll leave the chat room up and running. If you guys want to hang out and chit-chat, just be cool and be kind. Thanks for watching, guys, and be safe out there.